So this will be take 2 of 5.3. My competency for 5.3, which is wedges and screws. We're looking at these 3 blocks and just kind of how we would analyze a problem where we find P and figure out which one will happen first, I guess. And by doing so, we'll find P. So we have 2 kind of scenarios we have to look at here. One is where they move all together, which is this free body diagram. And like none of this work, actually just this work. Everything else is for part 2. But yeah, they move together, so we analyze that. So we draw a free body diagram, big block. Our weight is 1,250 pounds. And then we have to find, we know our normal force then. We have P pushing against it, which means we need something to counteract that, which is our force of friction here. Our force of friction is mu of S at that point, times our force going down there, or actually times our normal force, sorry, not our force going down. They're equal, but times our normal force technically, which gives us 625. So that's the force that it takes to move them all together. Now we get to our second option, which is where block B here slides up. The first step I did, again, draw a free body diagram, label all my forces and different things. This is the real sticking point for this one, is getting everything down. Actually, the first time I did this, and the first time I recorded this video, I missed this force of friction here, just because I just kind of missed it. And as I was going back through explaining it, I caught it. But so yeah, we have our just our free body diagram. This force of friction is mu s, force normal. That's just basically what they all are. You just have to pick the right normal force. But like, we'll just look at this block and just say, okay, if I have my weight, so I got my normal force, and then I have a force pushing against me from block B. Even if block B is sliding up, it's going to be pushing against me, so I'm going to be what's kind of making it slide up. And it's sliding up me, which means that the friction is going this way. But if I'm stationary and block B is moving up, it's going to slide against me, just kind of like this, going up. So that's why this is up. That makes that down. You get that normal force, and we also have this force of friction preventing motion, because if block A moves, block B can't slide up. So same thing here at block B, same type of stuff. And this, one way to check this too is if you're block B, you're moving up, but to you, you're stationary technically, so block A is sliding down. It would be technically sliding down you, so then you're going to feel it down. And it should just be the inverse of these anyway. They should just be flipped. They should be opposite, I guess, not necessarily inverse. Excuse me. But yeah, so they counteract each other, so we don't have a moment due to friction, or so we don't have movement due to friction. That would be a little weird. Here, same thing, same idea, but there's no force of friction because we're at the point right before B is going to slide up. So it's technically, you can think of it as almost hovering right above the ground, to where there's not going to be a force of friction because it's not going to have any impact on it. So make sure you don't include that if you have a situation like that. And we just did block C here, and then I was doing some calculations, and then I realized my video cut off, so that was fun. So that's what a lot of these are. But I just started on this block because it has the least number of unknowns. It just actually has the one real true unknown. Because this we can find is just mu s of 0.5 times our weight, or our force of normal, I guess. Our force of normal, not the weight. It's times our force of normal. So yeah, I find that, and then I can find my F of A, and then I find my NA, find my F of A. It's same here, same there. You just kind of work your way left to right here. Just because this one had the least number, this is a lot of unknowns. This is a lot of unknowns. This one had honestly one unknown. And it had technically 3, but I find that one, and then I can find that, and then I can find that. So that was pretty easy there. And yeah, like over here, you're gonna have to use some, excuse me, you're gonna have to use some trig, some geometry to find N of B. But when all this work is said and done, and then you'll eventually sum your force in the X and the Y. And when all your work is kind of done, you're gonna get a value of around 1,020, I think, if I remember right now. Either way, your value is significantly higher than 625. So what that tells us is if we apply a force and it slowly increase that force, you know, to an infinite amount, I guess in this case a little over 1,000, what's going to happen first is our blocks are all going to slide as one. So this is what's going to happen, which it makes sense as you kind of think about it all the way. You're like, that makes a lot. I mean, it makes sense. I guess you could say, you know, okay, maybe it's not, you know, maybe that will slide up because there's a lot of friction, but with that force of friction being the same, it makes a lot of sense that they'll move together first. I feel like a situation where it wouldn't is if this had a lot higher force of friction than this, or a lot higher coefficient of friction, which would make a higher force of friction, I guess, yeah. That would be a situation where it could potentially be more, but yeah, that's just kind of how you go about it. The free body diagram, getting that right is the hardest part, and then it's just trig, and you kind of summing your forces and figuring out, you know, how I solve for this, what I need to solve for next. This one's super nice because you can work left to right. I mean, almost perfectly left to right and solve everything. And yeah, you get that, so then that tells you that, and these are your p-values, just the force of a push that it takes to achieve each of those. So yeah, this is 5.3 wedges and screws, and if you were asked the question like which one will happen first, your answer would be they're all going to move together because that had the lowest force required to move it.